So it's given that the particle starts at 21 meter per second and acceleration is given by this one. So we need to find few things: maximum velocity, maximum distance, the time it takes to return to its starting point, and its velocity at that time. So acceleration is 20 minus 2t. We can find velocity by integrating this one. So yeah, we'll just write acceleration directly. So that's there. So this is becoming 20t minus 2t square over 2 plus c, that's v. Now it's given that it starts at 21 meter per second. That means at t is equal to 0, v is equal to 0. So we have c as v is equal to 21, sorry. So we have v is equal to 21 when t is equal to 0. This is 0, this is 0. So basically c is 21. So velocity becomes 20t minus t square plus 21. That's the expression of velocity. Now we need to find the maximum velocity. At the maximum velocity, dv over dt, that is acceleration, will be 0. So dv over dt or acceleration will be 0. So 20 minus 2t, the acceleration was given. So we can, from here we get that at t is equal to 10, velocity will be 0. So we can plug in that value into value of t into this equation to get the velocity of value of velocity at the when it's maximum, basically, or the maximum velocity, basically. So 110 square plus 21, so that gives us 121 meter per second. So that's the maximum velocity. At t is equal to 10, the velocity becomes maximum, and that's the value of the maximum velocity. Now we need to find the maximum distance. So first we need to find distance, which will be again integrating the velocity. So 20 t minus t square plus 21 dt. So if we integrate it, it will become t square over 2 minus t cube over 3 plus 21t plus c s. So we can assume that at t is equal to 0, s was 0, which is a reasonable assumption. So if we do that, c becomes 0, because this is 0 and everything is 0, c is 0. Basically 0 plus c. So c becomes 0. C is 0, basically. So S is 10t square minus t cube over 3 plus 21t. That's the expression of x. We need to we need to find the maximum distance. So at maximum distance, again velocity ds over dt will be 0, that is velocity will be 0. So basically the particle is going in one direction, it reaches maximum distance, and then it returns, the velocity becomes negative. So before the velocity becoming negative, that is before the particle starts turning back, the velocity here will be 0. So if we equate the velocity equation to 0, which is 20t minus t square plus 21 is equal to 0, we get 20t, let me do it. So maybe I will do just middle term factor. So minus 20t minus 21 equals to 0. So we get t square minus 21t minus t minus 21 equals to 0. So that's t is equal to t minus 21 plus 1 t minus 21. This will be minus 21 plus t, sorry. So that's there. So t minus 21 or t plus 1, 0. So t is 21 or t is negative 1, which is not acceptable. So we can ignore this one. So basically when time is 21 seconds, the distance becomes maximum. That's when the velocity changes, velocity direction changes. So velocity sign changes, basically. So s is 10t square. S is 10t square minus t cube over 3 plus 21t. So if we plug in 21 here for t, we get sx max. I will just double check if I got the equation right. Yep, this one. So minus 21 cube plus 21 times 21. so that gives me 1764 meters. So that's the maximum distance. Now we need to find what else. We need to find the time it takes to return to the starting point and the velocity at that point. So when it returns to the starting point, s becomes 0. So we can just take this equation and solve it for the distance equation, displacement equation, and solve it for t, which will be t cube over 3 plus 21t. So that becomes, if we take t separately, it will become t square over 3 minus 10t minus 21, that's 0. So with the t is equal to 0, this is one solution, which is because when it starts at t is equal to 0, the displacement is 0 because it was at the original position. So that's done. We need to find the other time when it comes back to the original position. So t square minus 30t minus 63 equals to 0. So when we solve this one, it's a quadratic equation. I will use just 2a, 2 times 1 minus b, which is 30, plus minus b square minus 4ac, so 4 times 63, that will be minus 4ac, so that is also minus, that will be like that. So this is becoming 2, here it's 30 plus minus 900 plus 252, I guess, yes, 252. So this one finally becomes 30 plus minus 33.94, which since it's time we have to round up, so it will become 30 plus 34 over 2 plus minus, so it becomes 94 over 2, sorry, 64 over 2 or minus 4 over 2. Of course we can discard this one because that's negative, so we get 32. So rounding up this to 34, so 32 seconds. After 32 seconds it will come back to its original position. And what's the velocity at that time? I won't do this part anymore, I will just leave the so that's velocity 20t minus t square plus 21, 20t minus t square plus 21, that's the velocity equation. So we just plug in value 32 here and we get the, yes, that's the one. So if I do it, 32 minus 32 square, we should get a negative value because the velocity is now in the other direction. So that's 6640 minus 32 square, which is 1024 plus 21, so it becomes 405 and negative because of that negative sign, so meter per second. So it's in the other direction, sorry, negative, and the sign means that it's going in the other direction, of course. So